Hi, Honors Algebra 2. This week we're going to be looking at polynomials, and so I hope that this is something that is a good review at the beginning as well with exponent rules, and then we'll go through how we name polynomials and combining like terms and multiplying, and so I hope a lot of this will be stuff that's comfortable for you. So let's just go through a couple things. A monomial is just a single term. So it can be a number like 3, a variable like m, or a product of numbers and variables like 2x. So that's a monomial, mono meaning one term. And then we're going to go over exponent rules. So product rule, remember if we have a to the m times a to the n, we're going to add those exponents together. If we have a power to a power, a to the m raised to the n means we're going to multiply those exponents. Quotient rule, again, dividing means we subtract those exponents. A negative exponent, remember we talked about this recently in class before. If we have a to the negative x, we're going to move that whole term that has the negative exponent to the denominator. So we're going to rewrite that as 1 over a to the x. And then remember, a to the 0 equals 1. Okay? So you got to remember those rules excuse me, when we are multiplying or dividing. Okay, so this next little section of examples that I have for you on my notes, when we're adding or subtracting, we combine like terms, but when we're multiplying or dividing, we're going to use those exponent rules. And so I say multiply or divide like parts, meaning let's take our constants multiplied together, let's take our variables multiplied together. So 5 times negative 7 is negative 35. X squared times x to the 6th. We add those exponents, we get x to the 8th. Let's go on to number 2. We are going to raise each part of this term to the second power. So I'm going to get 4 and then a to the 6th and then b squared. And then I'm going to combine like parts. So 4 times 8, a to the 6th times a, and then b squared times b to the 9th. Okay, and then number 3, when we divide, we again divide like parts and we're subtracting those exponents. So we end up having like terms here where we have 18m to the 4th n cubed minus 10m to the 4th n cubed. All right, and then we've got more multiplication. Negative exponents just means when we add, if I get a negative exponent, that term that has the negative exponent, which is k to the negative 3, that term moves to the denominator. 10 stays in the numerator because it doesn't have a negative exponent. Okay, 5 is really similar to number 2, so I'll probably not talk through that one, but let you take a look at it. Number 6, you could do a number of different ways. I could simplify first and then take everything to the negative 1. So I didn't do that. I took everything to the negative 1 first. So I just flipped it and made 7w to the 3rd go to the numerator and 14w to the 12th go to the denominator, and then did subtraction. So it really doesn't matter in that case. This one is really similar to number 3, just divide like terms. I have a negative exponent though, so I want to make sure that I move that x squared to the denominator. Number 8, when I subtract here, I would get c to the negative 4, but I'm taking that times c to the 4th, so when I add those exponents together, I get c to the 0. Okay, polynomials. So polynomials is the sum or difference of many monomials. So lots of terms put together, and that is kind of the key right here, the sum or difference. Okay, so I'm going to highlight that actually, I think. So sum or difference meaning terms are separated by addition or subtraction. Okay, the highest exponent of a polynomial is called the degree. Standard form, we're used to seeing this with parabolas, but we start with the highest degree down to the smallest, or the constant if there is one. And then I put in alphabetical order, and I'll talk more about that in a second. But this is standard form of a parabola because we go ax squared plus bx plus c. So 10, 11, and 12. Number 10, I just start with the highest degree, which is 5, then 3, then 2, then 1, then technically 0. is constant, okay? And then 11 and 12, this is why I said in alphabetical order. So these are a little bit tricky. When you have multiple variables multiplied together, you add the exponents to figure out the degree. So a squared, b squared is a degree 4. ab is degree 2. Okay, so when I'm writing everything, I write them in alphabetical order with the highest degree down. So I start with this first term, a squared, b squared, because that's degree 4. Then I have a cubed, that's degree 3. Then 7ab is degree 2, and so is b squared. So that's why I talked about alphabetical order. This one has an a in it, this one doesn't. Okay, and then I'll let you take a look at number 12 and see if you can make sense out of that one. Okay, next thing, naming polynomials. So there's two ways for us to name polynomials. First is the degree. So obviously if there is not a variable, x to the 0, for example, is just 1. So that would be a constant term. Degree 1, we know x to the first is linear. Degree 2, quadratic. Degree 3, cubic. Don't mind my kids yelling in the background. X to the 4th is quartic. X to the 5th is quintic. Okay, and then we also classify by number of terms. 1 term is a monomial. 2 terms, binomial. 3 terms, trinomial. And once we get to 4 and beyond, we just call it polynomial of however many terms there are. So go through, let's double check these. Linear binomial, 2 terms, highest degree is 1. Quintic trinomial, highest degree is 5, 1, 2, 3 terms. Constant monomial, cubic polynomial of 4 terms. See, there you go. That's an example of that last one down here. This is a quadratic trinomial, a quartic monomial. Okay, so I hope that's kind of making sense. You might have a section about that, but this is the main idea though, adding and subtracting polynomials and then multiplying and dividing. So we're gonna combine like terms and write your answer in standard form, highest exponent down to the lowest or the constant. Okay, we can combine like terms either horizontally or vertically. Vertically is when we kind of line up, so I did a couple examples like that. And then my hint is distribute the subtraction. So if you distribute that first, then it just becomes an addition problem. It makes life a lot easier in my opinion. So standard form, I'm going to start with my x squared terms. Okay, I have 3 of them, and then 1x squared gives me 4x squared. 11x minus 5x gives me 6x. And then 4 minus 13 gives me negative 9. So that would be combining terms horizontally. Number 2 is an example of lining everything up in standard form and then combining vertically. So there's no other n cubes. Here I have n squareds. I line them up, add them together, n's, and then constants. Okay, 3 and 4 are subtraction. So the first thing I did, distribute that negative through. So this one again, just lining up and then combining like terms, no other k cubed. Okay, I have negative 2k squared minus 2 more k squareds gives me negative 4k squareds. I have a 2k squared, but minus 2k cancels out, so I'm just left with negative 16, or sorry, negative 17. Number 4, I line them up after I distributed the negative. So standard form when you line up to make sure that you're combining like terms. Okay, and then number 5, I just set this one up. Maybe you want to try it, but I would take, when it says subtract this from this, I'm going to take this term minus that. Okay, multiplying polynomials. You have a couple of options. You can distribute or FOIL. So distributing is what I would call modifying FOIL, or you can do the box. Okay, so for number 6, we're going to take w times each of the terms, and I did those in red. Check my math there. Okay, and then I did the same thing with negative 7 times each of the terms, and I wrote that in blue. Again, go ahead, check my math there. I think we're good. Then we're just going to combine like terms. No other w cubes. Then I have w squareds, w's, and negative 7. Okay, and I left a couple blank here, so if you want to try some, you have the opportunity to do that. The other option is make your box. So put w minus 7 on the side, w squared plus 2w plus 1 across the top, and then kind of like a Punnett square, we multiply, 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 and then multiply this way. And then our like terms are pretty cool. They should be on our diagonal. So I have no other w cubes. Here's my w squareds. Here's my w's, and then my constant. Okay, for ones like number 8, I kind of tried to box around what I did first. So I decided to just distribute or FOIL between those first two binomials, and that's in green. So I got a squared plus 3a minus 10. Then I'm going to take that answer times a plus 8. Okay, so I distributed all of those combined like terms there, got my answer in red. So you can either box it or do what we did up with number 6. Double check my math and make sure we're good there. And then my last step, I distribute. The reason I do that is so that we make sure we only distribute the one time. We don't take -3 through all of these binomials. That's wrong, okay? Because then I'd actually be multiplying by -27. You could take -3 just times the first one and then distribute and FOIL, and that'd be fine too, okay? So those are kind of your options. I left a few more blank here on the notes, so if you want to try going through some, you can. I wanted to give an example of a trinomial times a trinomial. So you could multiply all of it out here like we did before, but honestly, I think once you get to big numbers like these, or at least multiple terms, make the box. So that's what I did here, is I just made the box, multiplied here, and then multiplied here, and then like terms should be on those diagonals, add those together, double check my math, this is what I got. Okay, number 12, I gave you the area of a trapezoid if you want to try that one out. Okay, and then dividing polynomials. This is just by a monomial, just to get us kind of warmed up for something that we could get to next week or the week after, where we actually do some division with polynomials. So remember, we're going to just divide each term by the numerator, or sorry, each term in the numerator by the denominator term. So I'm going to take 9m cubed divided by 3m. Well, 9 divided by 3 is 3. M cubed divided by m is m squared. Negative 24m squared over 3m, divide negative 24 by 3, I get negative 8. M squared divided by m is m. Okay, and then make sure your answer is in standard form. So highest exponent down to the least or to the constant, and rewrite any of the terms with negative exponents. So 16 was another one. I just decided to go through, double check my math there. 15 one like this, if you're multiplying by something that has an exponent to the -1, you could literally just write that out. So for example, just rewrite this as all over 2ab. Don't judge my writing, guys. This is really hard to write with a mouse pad, so that's why my handwriting is not quite on point like it can be. All right, well, I hope that helps with the first assignment.